Hey everyone, this video is a review on writing equations from word problems, but we're also going to take a look at how we can write these equations using systems of equations now that we know how to solve systems of equations. So here are some things that we should do when setting up word problems. So first thing we want to do is always underline or highlight all the given information. So let's look at example number 1. It says Sarah has a brother who is 3 years older than she is. So um 3 years old, sorry, younger than she is. That's key information. Okay, her brother is 3 years younger than she is. The sum of their ages is 23. That's also key. How old are Sarah and her brother? So we want to figure out how old Sarah and her brother are. So the next thing it says is to determine what you want to find out. So I'll highlight in a different color how old are Sarah and her brother. So that's what I want to know. Step 3 says to draw a picture if you need to. In a question like this, I don't think it'll be necessary to draw a picture, but if you want to, go for it. Step number 4 says to write let statements, but always, this is so key, always ask yourself, how many things do I not know? So in this question right here, in example number 1, we don't know how old Sarah is, and we don't know how old her brother is. But we also, so if you look here, it says what we used to do. So what we used to do is we figured out, well, we have to see who everybody is based on. So it says Sarah has a brother who is 3 years younger than she is. So we need to know how old Sarah is first to figure out how old her brother is. So here we're going to say let Sarah's age equal, and then you can call it any variable you want. Now, what we used to do only involved one variable because we only knew how to solve an equation with one variable. So we still need to have one variable. So here we're going to say let her brother's age, and her brother is 3 years younger than she is. So it would be X, Sarah's age, and then minus 3, because this is 3 years younger than her. So this right here would be Sarah. You don't have to write this out. I'm just showing you this right here. And then 3 years younger. That's what's happening here. It's younger by 3. Okay? All right, cool. Now, the next thing that we need to do is write your equations. And just a reminder that the number of variables tell you the number of equations. So in this example right here, we only have one variable, so we only need to write one equation. Where do I get my information to write my one equation? From this right here. The sum of their ages is 23. If I know that the sum of their ages is 23, then I can take Sarah's age, her brother's age, add them together, and that would equal 23. So here I would just say x plus x minus 3 equals 23, and then I can collect like terms and get 2x minus 3 equals 23. Okay? And then I can go through and I can solve for x here. So let's go ahead and solve for x. Add the 3 to both sides. We get 2x equals 26. Divide both sides by 2, excuse me, you get 13, which means that Sarah is 13 years old, because Sarah's x, and then Sarah's brother is 10 years old. So then we can say, therefore, Sarah is 13 years old and her brother is 10 years old. But I have some good news for you, because setting up these let statements are difficult sometimes when you can only use one variable. Now we are allowed to use 2 different variables. So there's still 2 things that we don't know. We don't know Sarah, well, assuming we hadn't solved this already, now we know, but let's pretend like we don't know. We don't know Sarah's age, so we'll still call that x, but now we're allowed to say her brother's age is y. We're allowed to call it a different variable now that we know how to solve equations with more than one variable in it. This is awesome. But next, it says write your equations, and we have to remember that the number of variables will tell you the number of equations. So because there are 2 variables, we have to write 2 equations. So, what are my two equations? My two equations are going to come from the fact that Sarah has a brother who is 3 years younger than she is, and the sum of their ages is 23. So this is going to be our first equation. This is going to be our second equation. So if Sarah has a brother, Sarah's brother's age is, so this is Sarah's brother's age, is means equals, this is 3 years younger than she is. So we would take her age and then subtract 3 from that. Okay? But then we need a second equation, and our second equation is going to say that, so we'll call this equation number 1. Our second equation is going to say that the sum of their ages is 23. So I take Sarah's age, which is X. I take her brother's age, which is Y, add them together, and I get 23. And then in order to solve for this, I would sub equation 1 into equation 2, and then that would look like this. So here I would write down X plus, instead of Y right here, I can replace it with X minus 3 because that is what Y is. And then I get equals 23. And now this looks exactly like what we did right here. And then the solution is going to be exactly the same. Okay? All right. In example 2, we're going to go through and use these steps that are listed out here, just like we did in example 1. So the first thing we want to do in example 2 is underline or highlight key information. So it says the school sells tickets to the play at a cost of $7 for adults. You probably want to highlight that and not cross it off. $4 for children. Twice as many adult children attend as adults. And the school raises $225. How many adults attended? So I'm going to highlight what I want to figure out, which is how many adults attended. Then I want to see if I need to draw a picture. Drawing a picture isn't really helpful in this example. So step 4 would be to write my let statements. And that is going to be the key piece of this. So what we used to do with one variable is, first of all, we want to think, well, how many things do I not know in this problem? And I don't know the number of adults and the number of children. Which one depends on which? Well, in order for me to be able to find out the number of children, I need to know the number of adults. Why? Because it says twice as many children attend as adults. So this means right here that I need to know the number of adults first before I can find the number of children. So be very specific. Do not just say let adults equal or let adults be. We say let the number of adults equal, and we're going to call it X. And then because we're only using one variable, we're going to say let the number of children, and we know it's twice as many. So I'm going to take the number of adults and multiply it by 2. So I'm going to write 2x. Okay? But now I need to write my equation, and my equation is going to be based on costs. So it's $7 per adult. So I would do 7 times x plus $4 per child. So I would do 4 times 2x, which can tend to be very confusing. And that would be $225 altogether. Okay, so now I would multiply these two numbers together, these two expressions together. So I would get 8x. Collect my like terms, I get 15x. Divide both sides by 15, and I would get 15. So here, I know that the number of adults is 15, and the number of children is 2 times as much, which is 30. So we could say, therefore, there were 15 adults and 30 children. But we can also make sure that this is right, because if it's $15 per adult, but we can also double check to make sure that this is right. So if there's 15 adults at $7 per adult and 30 children at $4 per child, multiply these numbers together, you would get 120 over here, and then 15 times 7 would be 105. And then you could add those together and we would end up getting 225. So we know that we did this right. This is tricky to do this with one variable. It's actually easier to do this with two variables. Why is it easier to do this with two variables? Well, for starters, I don't have to ask myself which one depends on which. I could just write my let statements. So we could just go straight to let number of adults equal A, let number of kids or children equal C, just using the letters for adults and children, that the letters that these words start with. Doesn't matter what letters you use. It also wouldn't have mattered if I wrote children first and adults second, it wouldn't have mattered. So here's the thing though, we need to write two equations. One equation is going to be based on cost. And the cost tells me that it's $7 per adult plus $4 per child, and altogether that should equal 225. But because I have two variables, that means I need two equations. And because I need two equations, I need another equation, and that's going to be based on the number. And we know that twice as many children attend as adults. So the number of children is equal to 2 times the number of adults. And now I can sub 2 into 1. And here I would get 7a plus 4 times 2a equals 225. And then I'm back to this spot right here. And that's it for this video. Let me know if you have any questions. Otherwise, we'll see you in class.